This is quite a difficult problem, but much simpler if we just notice that the focal date is 4 years from now. So here I've listed the different events. A, you borrowed $800 2 years ago, so that would be 2 years from today. And also you borrowed $1,000 5 years, and it's due in 5 years. And we're going to replace those with two equal payments, which I call X. So this is basically an equation of equivalence. We need to set up an equation of equivalence. So the two things that you borrow, the 800 and the 1000, have got to be paid off by two equal payments of X, but we don't know what those are. But we do know that they are the same. And also we know all the dates between the different events. So we need to work out the value of the two debts, that's $800 and 1000, at the focal date, and at the focal date the value of the two repayments that you're going to make, that's on the right hand side of the equation, of X. So notice here that the first one of $800 is behind the focal date. In other words, it occurred before the focal date. So therefore, this is going to be a future value calculation. But the other thing that you borrowed, the $1,000, is after the focal date. So therefore, this is going to be a present value problem. So on the left hand side of the equation, what you borrow, we have one future value and one present value problem. Now looking at the repayments, that's pay X. This one is at the focal date, and so there will be no interest factor at all involved in it because it's exactly at the focal date. The other one, the second one, pay X, is after the focal date, and this therefore will be a present value. Now underneath I've listed the number of years between each event, and I think it will be helpful to you to sketch these out in the same way as I've done and make sure you can follow the calculations. Now here are the calculations. First of all, we have the future value of the $800. So I equals J over M, so that's 12%, compounded semi-annually, and then we have 2 semi-annually and 6 years. Plus, now remember that that $1,000 was after the focal date, so therefore we have a present value. This is a present value equation. The interest terms are exactly the same, so the I is the same. It's compounded semi-annually, but it's only 1 year after the focal date. Now this equals X. We only have X here. This is the X that is repaid on the focal date. And then there's another X. It's exactly the same in size, but it's divided by this interest factor here because it's a present value. This second X occurs after the focal date. Now we can do a calculation. We can work out the size of the first one, and then we have here 890, which is the $1,000 present value, equals X, and then X over 1.59. Now here you can see these things. Now the thing is, what we need to make sure that we bring the X here. So this is 1.63X. So the 1 is from the first X, and the 0.63 is the reciprocal of 1.59. So you put 1.59 into the calculator, make it a reciprocal, that 1 over x, and you will get 0.63. Add this to the 1, and we have 1.63x. We can finish it by dividing both sides by 1.63, and we come x is 1533.6. 2 equal payments of 1533.6. Thank you.